Hello! For the case study of this lesson, we want to talk about the Special Toys project. Our group members are Simge Çuadar, Oğuzhan Yener, Mustafa Kerim Acar, Esin Gedikoğlu, and Deniz Sarı. During presentation, we tried to solve the problems of this case. In this case, there is a company named Special Toys and they sell a variety of new and innovative toys for children. They are producing toys basically. Management learned that the pre-holiday season is the best time to produce a new toy because of the holiday gifts. They plan to introduce a new product called Weather Teddy. When children press the bear's hands, it talks one of 5 responses. It looks to be a very nice day. Have fun. I think it may rain today. Don't forget your umbrella. Tests with the product show that the bear's predictions are surprisingly good. Now here we have some information about draft of our new toy. For example, member of management recommended to order quantities of 15,000, 18,000, 24,000 and 28,000 units. Expected sale price $24 per unit. Cost $16 per unit. Surplus inventory sale price $5 per unit. Sales forecasted prediction of expected demand $20,000 units with a 95 probability that demand will be between 10,000 units and 30,000 units. Now here we have the first problem. Use a sales forecaster's prediction to describe a normal probability distribution that can be used to approximate the demand distribution. Sketch the distribution and show its mean and standard deviation. First, we write the data as a table. Then, for the down area of the curve, we calculate y minus probability of demand will be between 10,000 and 30,000 divided by 2. For z-score, we calculate max quantity 30,000 minus expected demand divided by deviation. After that, we calculate normal distribution for values between 10,000 and 30,000. For this estimation, we use Excel formula norm.dist. In the formula, respectively, we choose quantity, expected demand, then deviation, and for cumulative, we choose false. With these values, we draw the line chart for normal distribution. This is the solution for the first problem. Here you can see the normal distribution chart. Then here is the second problem. Compute the probability of a stock out for the order quantities suggested by members of the management team. For this question, we write down our suggested quantities first, then estimate the mean and deviation. After that, suggested quantity minus mean divided by deviation gives us the z-score. For the px, we use norm.dist again and respectively choose suggested quantities, mean, deviation, and true for the cumulative. 1 minus px gives us the pt bigger than x, and this is the solution table. Our third problem is compute the projected profit for the order quantities suggested by the management team under 3 scenarios. Worst case in which sales 10,000 units, most likely case in which sales 20,000 units, and best case in which sales 30,000 units. Again, first we write down all the data we have. Let's start from the worst case. We multiply the worst case quantity with price of teddy bear for sales. For the surplus, expected quantity minus worst case quantity divided by surplus inventory. Our cost is expected quantity times cost. And finally, our profit is sales plus surplus minus cost. We make these calculations for all of the cases just changing the quantity because we have 3 different quantities for our 3 different cases. And finally, in our scenario quantity table, we can clearly see what happens in different numbers and how our profit affected from these quantities. Now here is the other problem. One of specialties managers felt that the profit potential was so great that the order quantity should have a 70% change of meeting demand and only a 30% change of any stock outs. What quantity will be ordered under this policy and what is the projected profit under the three sales scenario? For sold order quantity to meet 70% demand, we have Pz smaller than K. We take Z as 0.70 and from Z table, K becomes 0.5244. 20,000 plus deviation times K is our quantity. We know our cost, price, and surplus from former problem. Price times expected quantity gives us the sales. Quantity minus expected quantity times surplus gives us the surplus, and quantity times cost gives us the total cost. Last step for find the profit, we calculate sales plus surplus minus cost. And here's our table. And here's the final question. Provide your own recommendation for an order quantity and note the associated profit projections. Provide a rationale for your recommendation. The order quantity that the company should maintain should range between 20,000 and 25,000. The management had determined that with an order quantity of around 22,676, the profitability of the company increases to 70%, and the probability of stock out reduces to 30%. Moreover, the most likely scenario considered by the company management is 20,000. Hence, keeping the order quantity between the range of 20,000 and 25,000 will neither put the company at risk of stock out nor keep excess amount of stock for the company. Moreover, the company will also be able to maintain a steady amount of profit in this range of stock. The probability of stock out for the company under the option of most likely range of ordering quantity is also low, that is 21%. Beater Teddy is a new addition to the existing product line of the toy company. Also, the product is designed in an innovative manner in order to provide to the needs of the children in an informative as well as innovative manner. However, since the product is a toy, hence it is not possible to measure the demand graph of the product, and it is not possible to judge the amount of ordering quantity in order to balance the situations of stock out. If the company adopts the best possible scenario and orders products ranging between 26,000 and 30,000, then if the product flops in the market, then the company may get stuck with the high levels of inventory in the warehouse, along with high levels of cost production and inability to recover the variable cost. In that situation, the company would have to sell the goods at reduced prices. Hence, it is advisable to maintain a lower level of ordering quantity initially, and after judging the demand level, the company can effectively increase the amount of ordered quantity.